Hello everyone, welcome to Ganet Gurukul and this is Yogesh Garg. In this video, we are going to discuss a problem based on sequence series and inverse trigonometric functions, and this video is part of the series daily practice problem. So let us start. We have sigma r is equal to 1 to k tan inverse of 6 to the power r by 2 to the power 2r plus 1 plus 3 to the power 2r plus 1. Then limit k approaches infinity as k is equal to. We have this question, right? Now, how to go about it? See, we know that these particular problems are typically of the difference method type questions. It involves the concept of difference method, that is breaking or telescoping series, difference method and telescoping series, that is breaking this particular expression into two consecutive terms, and then the sigma will do our job. It will be a telescoping series and eventually we will be having a simplified expression. Now what we have to do, we have to understand how to break this expression that is inside the bracket into two different terms, right? So we know that we have to write this expression tan inverse of 6 to the power r upon 2 to the power 2r plus 1 plus 3 to the power 2r plus 1 in this particular manner. Tan inverse, tan inverse of a minus b by 1 plus ab. So we should try to write this expression that is inside the bracket in this particular form, a minus b by 1 plus ab. So if that is so we should write this expression in this particular form. We have 6 to the power r by 2 to the power 2r plus 1 plus 3 to the power 2r plus 1 is equal to a minus b by 1 plus ab. It is very obvious that we have 1 in denominator, so either we should divide the numerator and denominator with 2 to the power 2r plus 1 or by 3 to the power 2r plus 1. Let us say I divide this expression numerator and denominator both by 2 to the power 2r plus 1. Fine. So let us proceed with this. 6 to the power r upon 2 to the power 2r plus 1. I will simplify this in the next step. Upon 1 plus 3 by 2 to the power 2r plus 1. I hope you are getting this. Power are same, base are different. That's why I have written it as 3 by 2 to the power 2r plus 1. And we have to compare and contrast that AB should be equal to this 3 by 2 to the power 2r plus 1 and a minus b should be equal to this numerator, but let us also simplify this numerator. So what we have in numerator is 6 to the power r, fine. So we should simplify the numerator, 2 to the power r into 3 to the power r upon 2 to the power 2r plus 1. This is 2 to the power r. It will break the denominator in this particular form, 2 to the power r plus 1. Fine, this is our numerator and denominator is 1 plus 3 by 2 to the power 2r plus 1. Fine. Now let us proceed even further. This is 3 to the power r upon 2 into 2 to the power r. In denominator we have 1 plus 3 by 2 to the power 2r plus 1. So now we have to think about it. The numerator should be of the form a minus b and this 3 by 2 to the power 2r plus 1 should be ab. What are the different possibilities for this? We have to think about it. We have to brainstorm, right? So denominator is numerator is, let us say, simplify it even more, 3 by 2 to the power r into half. This is a numerator. Numerator is equal to a minus b and denominator is the product, 3 by 2 to the power 2r plus 1. It is very much clear, that both a and b should be of the form 3 by 2 to the power r. Both a and b, it is very much clear that a should be something like k into 3 by 2 to the power r and b should be m into 3 by 2 to the power r. And if we subtract these two terms, a minus b, right, subtract this a minus b, it will be equal to k minus m into 3 by 2 to the power r. And obviously it is equal to, numerator is 1 by 2 into 3 by 2 to the power r. So that means k minus m is equal to 1 by 2. We have first of the expression. Also we can use the second expression, that is a into b is equal to second part of denominator. So a into b is equal to mk 3 by 2 to the power 2r. I hope you are able to understand. Power will get add up. We have 3 by 2 to the power r, and the second term is also 3 by 2 to the power r. So power will get add up, and we will have 3 by 2 to the power 2r. So AB is equal to mk into 3 by 2 to the power 2r. Now we will compare this with 3 by 2 to the power 2r plus 1. This is 2r plus 1 and that is 2r. So we can clearly eliminate 2r power. So finally we will have only 3 by 2. So k minus m is equal to half and their product is 3 by 2. Their difference is their difference is half and their product is 3 by 2. Just think for a moment. What can be the possibilities for k and m? What can be the possibilities for k and m? Their difference is half and their product is 3 by 2. Now we have to think of the possibilities. So either by hit and trial or by direct solving. How to solve it? Find the value of k plus m. Fine. So you can use that method, either hit and trial or direct solving, that is finding k plus m by using k minus m full square and then adding 4mk into it. So find k plus m full square and find k plus m, solve k plus m and k minus m to get the value of k and m. But if we use a little bit of common sense and hit and trial, I would say hit and trial, not common sense. This is nothing like common sense. So we can see that if k is equal to, or k is equal to 3 by 2, comma m is equal to 1 satisfies above equation. Our job is done. A is equal to 3 by 2 into 3 by 2 to the power r, and b is equal to 3 by 1 into 3 by 2 to the power r. That is, a is equal to 3 by 2 to the power r plus 1 and b is equal to 3 by 2 to the power r. Tan inverse of a minus b by 1 plus ab is tan inverse of a minus b. Tan inverse of a minus tan inverse of b. Tan inverse of a minus b by 1 plus ab is tan inverse of a minus tan inverse of b. Our job is done. Now this difference method is successfully applied, and now we will use telescopic series method. So finally we have that particular term in sigma from r is equal to 1 to k as, and please don't get confused by this k with that particular k. That k was just used to find the value of a and b. That k was not part of sk. Fine. So this is k. This is k is upper limit for sk, for the expression sk. Fine. And then we will apply the limit and k approaches infinity. Fine. So this is sk. R is equal to 1 to k, and term will be tan inverse of 3 by 2 to the power r plus 1. This is in brackets minus tan inverse of 3 by 2 to the power r. Fine. Now use the sigma over it. Fine. You can clearly see terms will start getting eliminated. So sk is equal to, first term will be tan inverse of 3 by 2 to the power 2 minus tan inverse of 3 by 2 plus, then you will have tan inverse of, put r is equal to 2, you will get tan inverse of 3 by 2 to the power 3 minus tan inverse of 3 by 2 to the power 2, and now you know the whole drama. It will goes on till tan inverse of 3 by 2 to the power k plus 1 minus tan inverse of 3 by 2 to the power k, and you know these terms, this term, second term, they will this sort of terms we should be very careful while eliminating the terms. So first term of the first series second term of the first term of the first part of the series, first term of the first part of the series, and second term of the last part of the series will get eliminated, and except these two terms, all others will get eliminated, except first part of the last series and second part of the first series. Except for these two terms, all will get eliminated. You will have a complement or a additive inverse of tan inverse of 3 by 2 whole cube in the third part. Fine. So all other terms will get eliminated. I hope you know this telescopic method. So finally we will have sk is equal to tan inverse of 3 by 2 to the power k plus 1 minus tan inverse of 3 by 2. But our job is still not done for final answer. Now we will apply the limit. We will apply the limit k approaches infinity. So limit k approaches infinity, tan inverse you have 3 by 2, that is greater than 1. Anything greater than 1, if raised to the power infinity, it will tend to infinity. So we have tan inverse of approaching infinity, and second term is constant. There is nothing like there is no expression for k, so it will be constant. It will be the same, tan inverse of 3 by 2. Tan inverse of approaching infinity is for what value of for what angle between minus pi by 2 to pi, between minus pi by 2 to pi by 2 does tend to infinity. It is for pi by 2. So this will be, first part will be pi by 2. So we have pi by 2 minus tan inverse of 3 by 2, and we know pi by 2 minus tan inverse theta is pi by 2 minus tan inverse x is cot inverse x. So this will be equal to cot inverse of 3 by 2. So our answer for this particular problem is cot inverse of 3 by 2. Cot inverse of 3 by 2 will be the answer to this particular problem. So the concept involved in this particular problem was difference method, this breaking the term inverse trigonometric, whatever say property of inverse trigonometric functions, difference method, and telescoping series. Fine. Properties, two properties. I would not say just one property, two properties. First property, this tan inverse of a minus b by 1 plus ab is equal to tan inverse of a minus tan inverse of b, and the second property was pi by 2 minus tan inverse of x is equal to cot inverse of x. So the application of two properties, then difference method, then telescoping series. So I hope this video was clear to, this question was clear to everyone, and if you have any doubts, so please do ask in the chat, and keep watching Gurukul. Stay tuned. We will meet in more such videos.